Okay, welcome to the fourth installment, I suppose, on functional groups, and we are going to start talking about amines. Um, the suffix for amines is, of course, amine, and the symbol, the formula that we use is NH2. It's the functional group is basically NH2. The numbering rule is the same as any other substituent. You can have an amine group uh, basically anywhere. So, like any other substituent. A few common amines. We're going to start with the amine for the parent hydrocarbon of methane. So, it's called methane. You remove the E and you write just amine. So methanamine. And how do I draw it? You have the CH4 group, but instead of one of the hydrogens, you have the NH2 group attached to it. What's the condensed structural formula? CH3 NH2. Next one is ethanamine, which is CHHH CH2 NH2. Condensed structural formula CH3 CH2 NH2. Next one, propane 1 amine. You have to specify the one here because there are two variations to it. So you could do C and you could have it attached to an N and then two hydrogens. All these are hydrogens, so please excuse me for not putting them down. The next one is propane 2 amine, which would be C, 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 and then the NH2 group would be attached to the second carbon. Hydrogen, 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 hydrogen. CH3, CH, NH2, NH2, CH3. And that's pretty much it. These are the four most common amines. I'll just pause until you have taken this down, and then we move on to the next part. So there's a question that I wanted to ask you guys, and the question is, why is it that the boiling points are so different for methanamine and methanol, ethanamine and ethanol, propanamine and propanol? Obviously, you can see that they're higher. The alcohols have higher boiling points compared to the amine groups. So what do you think is the reason for that? So I'm going to give you I'll give you 2 minutes to do a think pair share, and then we'll get some answers from you. Thanks. Okay, so the answer to this question revolves around the strength of the hydrogen bonding. Both have hydrogen bonding. Both have hydrogens that are bonded to either nitrogen or oxygen. So it can't just be that one has hydrogen bonding and one doesn't. Both have it. The only difference is that in the case of OH, the electronegativity difference is higher, and you can check that from the Pauling scale. And as a result, the bond is stronger. The hydrogen bond is stronger. Since the hydrogen bond is stronger, the intermolecular forces between two alcohol molecules is stronger. And since that is stronger, boiling point is stronger. So, and amines have hydrogen bonding, but it's not as strong as OH. So that is the reason why you see this trend in boiling points. Now, if you have understood this concept, I would like you to go on to Lucarelli set 16, question number 10. I'll give you 5 minutes Actually 3 minutes, 4 minutes to go through it. 4 minutes. Time. Okay. So now we move on to another functional group. Don't worry, there are only 2 or 3 more, and then that'll be the end of the chapter. Um, this functional group is called amides, and the suffix is, of course, amide. The functional group by itself is C double bond. Now, if you remember the carboxylic acid functional group, just replace the OH, the OH with NH2. So the numbering position is like any other substituent. Any other substituent. Start naming. The first one, which is a derivative of the methane group, is methanamide. Methanamide, which would be CH3, structural formula, HCONH2. So if you remember, the carboxylic acid group was HC double bond OH, HCOOH. So if you replace the OH with an NH2, you get HCONH2. The general formula would be HCONH2. The second one would be ethanamide. Ethanamide. And that would be CH3 C double bond O NH2. 1, 2, 3, 4. Yeah, 4 bonds. So that gives you CH3 CONH2. I didn't need the bond here, so just ignore that. Just remove it actually. And finally, propanamide. Propanamide, which would be just CH3 CH2 C double bond O NH2. It would be CH3 CH2 C double bond O NH2. Done. Now, like any other group, it does have hydrogen bonding, because again the hydrogens are attached to the nitrogen, which is the primary condition for hydrogen bonding to occur. Okay, so just need to point out that I made a mistake here. Oh, sorry, not here. I'll go up. Made a slight mistake, which I need to correct. What happened? Yeah, so it's not actually like any other substituent. It can only be at position 1. So it's always at its terminal or always at the end, or always at end. Now let's follow this up with a question. That's why there's no propane 2-amide, by the way. It has to be just propanamide. You'll have only one at the terminal position. So if you have a look here, ethanamine has a polarity of 1.2, ethanoic acid has a polarity of 1.7, but ethanamide has a polarity of 3.7. How would you explain that? I'll give you a couple of minutes to think about this. Okay, so the reason for the polarity difference, the dramatic increase in polarity difference between ethanamine, ethanoic acid, and ethanamide is that there is an oxygen group present in close proximity of the nitrogen. So if you look at this oxygen group, that has some influence on the nitrogen as well, in pulling the electrons away from hydrogen, thereby leaving it with a greater partial negative charge and giving nitrogen a greater partial positive charge. As a result, you have a stronger hydrogen bond and thereby a stronger polarity. Okay, we'll stop here and we'll continue next time. Okay, another question that I want to bring your attention to is if you have a look at the acid group and the amide group, you would see a stark difference in the boiling points. And my question to you is, why is that difference there? Why is there such a dramatic difference between, let's say, propanoic acid and propanamide, given that both have hydrogen bonds? So I'm going to give you a couple of minutes again to think about this. Yeah, so the answer to that question follows from what we just discussed, that the oxygen group, which is present in close proximity to the nitrogen group, supercharges the hydrogen bond, and as a result, the amide groups would have stronger boiling points compared to the acid groups. Now, if you could go through question 11 from set 16, that would help us move on to the next part. So just question 11 set 16, and then we'll start esters.